So hello everyone, my name is Zafar, and next slide you will see my details, but for now just quickly about the topic and what we're gonna do today. This topic will be, let's say, a walkthrough for you guys who may not work or somehow related into this field of loan lending business. So as you may know, one of the oldest business that possibly can exist in the human history. So we're gonna talk about it right now, how it works in detail, and what basically the business model stays behind it. Yeah, so basically about myself, my name is Zafarzhon Irismetov. I'm a senior data analyst in the credit risk department, and currently, let's say my daily tasks are including scorecard development. We'll talk about what is a scorecard in the next slides. I'm working mostly with SQL, Python, R scripts. So regarding other tasks, it's some requests from the management sometimes, and that's feature engineering, what we're also going to talk about. And this request and other, let's say, data analytical part also includes in my job, and it's, let's say, can be in this risk concept box. Yeah, let's move on. So let's start, and this is a QR code to my LinkedIn. So if anyone later will want to connect, at the last slide there also will be the same QR code. Yes, agenda. I will not read it, just go through it quickly and we can move on. Okay, this is just for later if somebody want to revisit this presentation, maybe after this conference. So how it works, as you know, for right now, maybe most of you guys are borrowers, hopefully not, but maybe in the future, that you guys need money for anything. Another matter is it some kind of private stuff or just for the company. So you come to financial organization. Financial organization can be bank, fintech, or something else, and you ask them money. So they decide to provide you this money or not, but of course these financial organizations also need to have money to provide it to you. And how it works, some other people give them money. As we know that, for example, in banks it has deposits, right? So in banks you put your money on deposits, for example, to 2-3% a year interest, and banks then use this money to provide loans, for example, at 7-8% interest. So this 4% interest gap is actually the bank's profit margin. In other organizations, for example, in fintechs, usually they provide bonds. Bonds is a specific document that basically tells, okay, give us guys money, we'll give it each year some percent of interest back. So we like promise to give you back money and plus some interest on top of that. But it's a different topic. But the whole business idea is lying under this idea that the profit equals to this interest and the cost of risk, because we don't live in a perfect world, and the customers often or not often, depends on the risk, can be defaulted. Defaulted means that they cannot close their loan, so they are becoming, let's say, bad in terms of banking. Okay, so revenue, yeah, we have regulators usually. Yeah, default risk borrowers, risk price. Yeah, so, and this correlation, do you see? No, you don't see. Okay, so the correlation is if you provide loans to the high risk customers, then the interest also will be high. And that's logical, because this interest must cover the defaulted customers that would potentially appear in the future. Basically, Guys, I will not be very nerdy and go to each of these details, but this is very important in this lending business. The most important criteria is the probability of default. Basically, it says in how many, like what's the percent that for a given customer in the future this customer can become defaulted. And in this, I think in the banking it's around 2 and 8%. In the fintech it can be higher, though in the fintechs also the interest risk rates are also higher. So then we have this LGD. It's basically if client become defaulted, anyway, there is a collection service or some other service, we can collect some part of the money. So this is what it says. Exposure at default, how before becoming defaulted customer, how many percentage of the loan it closed. And DTI is basically telling how much of the monthly income that person gets, person can spend on closing the loan. So this, for example, if I get €1,000 and I pay 500 to closing my loan, so DTI is 50%, right? And let's say the Bible, but it's just a value, it's expected loss. This is what makes our business profitable or not. And as you can see, the PD is a core of this expected loss value. And this results to a profit to a company if everything works good and if management and risks work together properly. Also, we have a vintage analysis. It's when we track one specific group of people from, for example, quarter 2024, and we track how they behave over some time. And that's also show us did we do good decisions and how in general our process works. And it also can be divided into products. So there is many, for example, the product can be, like single payment products that you lend money for 1 month, for 1 week or something like that. Then installments for example, when you give money for a year, 2, and so there is a different product types. So maybe some of you already know that. About the modern day and how Python is exactly working with this stuff. We want money quickly. Sometimes it's spontaneous, and that's what makes a huge profit, especially in 21st century. Right now, traditional banks is lacking of this. No, at least not everywhere, but majority is lacking of this instant loans and providing as soon as possible the money. And for example, if you ask money on Friday, you need to wait an answer till Monday because they don't work on Sundays or on the weekends. But fintechs, they are very adjustable to that. You just send application, and right now there is a credit bureaus organizations, other organizations that collect information about the person's credit history, and we just ask them this information. So sending them the request, we pay them a little bit of some cost to get this information, and based on this information and plus clients personal data, we can almost instantly make a decision. We'll move into that right now. Yes, and of course, I don't know how in banking mostly use this AI. They applying AI to, for example, fraud detections. But in fintechs, it also depends on the scale of the fintech. For example, as far as I know, Revolut and Wise, if I allow to say these names, they are using some fraud detecting AI models in their system. However, some small or local based lending business fintechs are usually not spending too much time on that. So again, underlying tool for this instant decision making is a scorecard. Scorecard is a model that when you feed them some data about the client or application, this model spits out some number from, for example, 0 to 1,000, which represents the risk of the person. So for example, if the score is around 800, 900, we can pretty sure say that this client is safe, and probability of default of this client is very low. And vice versa, if this number is low, we might give lower limits to credit limit to the person, and at the same time provide him higher interest rate, because we think that this higher is riskier. And scorecards are usually is just in a production wise how it works. It can be just JSON or CSV file which represent these beans of some customer data. For example, starting from the age, we most of the fintechs assume that if a client is young, so it's actually a negative points. So we have some baseline score is around 500 or 600. This is from starting point where we start, and just at the end adding or removing some points, and this is our final score. The most important criteria of the scorecards, it should be understandable to the business, and you need to explain why, for example, some such decision this scorecard made. The problem why we can't use, at least in Baltics, we can't use deep learning, XGBoost, or something that have a black box, as you may heard somewhere, is that you cannot interpret the final result into some decisions. But you can with logistic regression, the old one, but it's very, very it's very, very it's a gold standard. It's used everywhere, starting from banks in fintechs, because it's very easy to interpret its result. If you got some probability and the logos, you can understand which points or which variables derived to the final results. And it's also pretty fast, because as soon as it's already in production, you just feeds the data, it provides your logos, and with logos you can already calculate the score. Above also one of the imported formulas, if you will be interested in that, it's probability of default, how it's calculated. So it's calculated like that, and it just provides you some percentage of if client in the future will become bad, as we call it. The development of the scorecard, it's also not very the development in if we say it's from the Pythonic point of view, just run the code, write the code, run the code, test it, etc. It's only like 20% of the time. 80% of the time it's data preparation and understanding exactly which features you want to use to train the model. The thing is, from credit bureau, at least now, we can get up to 1,000 different features. So how to decide which one you want to use? There is many different cases. How we can do it, we'll come to this question in the next slides. But right now, yeah, we just collect the just overview of the scorecard development. We collect the data from credit bureau, maybe CRMs, banks, etc. We select specific time period which we will use to train our scoring model. For example, if today is 2026, we'll use data for whole year of 2024, because we can say that the loans which was given in 2024. Okay, let's start from the beginning. At the start of the business, you don't have a scorecard because you don't have a data on which you can rely to train your scorecard, right? You just use risk analytics and risk management to provide loans. But as soon as some range of loans is already developed, you can use this data now to train the model. And again, if we have a data from 2024, we already can say that some loan in January 2024 is it become bad, or it successfully was painted, it stayed good. And using this data, we can later calculate the no, use it for the training. Yeah, we do the feature engineering. We do this binding. We'll talk about this in binding of features in the next slide. Then we train the model. Um, then we scorecard scaling, just calculating logos. It's easiest part. Then we validate the results, the model itself. There is we'll talk about also in the later. Deploying it, and we need to monitor it, production deploy. We'll come to up also into this. About the feature engineering, we use the technique of weight of evidence. And basically, it's a natural logarithm of percentage of good borrowers in some bucket or bin, and divided by percentage of bad borrowers also in the same bin. And this will give us, as you see on the graph, the weight of evidence. And if the weight of evidence is negative, so for that bin we give a lower score. This is just made up scores, but the logic is the following. So it should look something like that. And information value is showing us how at the end is important that specific feature. Yeah. Moving to the next, how we actually need to bind the features in the feature itself. For example, the age group. There is multiple different cases, but the one that I worked is the equal width banding. This is just usually prepared by some analysts, or if you are doing it, you just see at what point, using the just basic SQL, see at what point there is a PD difference starting to appear. And there is also a method you called monotonic binding. In this case, the example of the use case is that utilization means how many percentage of the maximum allowed loan person actually took. For example, if it's allowed to borrower to take 10,000, but borrower took, in this case, 2,000, that means utilization is 20%. And we can see, for example, depending on utilization, the default rate is different, and utilization on the 40-60%, default rate actually is lower than it's 61-80. So using this monotonic binding, we can actually find out that and just concatenate two groups and make just three binding groups. And that's a practical example. The first example is about the monthly income, and that allows us to calculate the debt to income ratio. And in this case, debt to income ratio falls into the bin 45% and we have a little bit negative weight of evidence. So that's just a sample how do we use the income data then to affect on our features. The Python implementation of just some example how it may look like in the production. That we first get the features, doing this binding process. For example, with optimal binding, we fit it into the model, train it, and then evaluate. And at the end, we have a metric which called Gini. Gini basically means discrimination metric is if you imagine you have 10 borrowers and you can rank them from 10 to 1, where the 10 is highest risk borrower and the 1 is the safest one. So this is how properly you rank them. And in the case of lending business, the higher Gini means it's your understanding of high risk borrower is probably very good to the model. Next one is how do we convert the results of the logarithmic of the logistic regression. How do we convert the result of the log odds to the actual score? There is a formula. So again, as I said, we have some base score. This is the anchor point from which we start. Then we have the PDO. It's how many scores should we add so that we have increasing the safety risk of the client. So, but let's say vice versa. So PDO means if we add 20 points, then that means that risk of the borrower to become defaulted is becoming lower by some percent. I think it was twice. So I don't remember that properly. Odds is usually 51, good to bad ratio, and factor calculated using this formula, and offset, and applying it both together gives us a score that then we can use to measure the client's application. How the whole flow looks like in production. Client creates an application, then we receive this application through some API. We send the request to the credit bureau, gather data, send this data to scoring engine, and there is a technical part that can apply due to some regulations, mostly due to regulations of some countries, which call the rule engine. It applies some hard rules. We'll talk about this just in the next slide. And then we spit out the decision. For the scoring, again, we convert the input to the scores, and then calculate the main score by summing them together. Again, some of the scores from the beans can be negative, as I said, and altogether they can create some specific score. About the hard rules. Hard rules can be different, for example, depending on the age, depending on the debt to income ratio. By the law, for example, customer is not allowed to get the loan if they pay more than 50% of their income to cover the loan. If it's so, you just cannot provide. Otherwise, audit will come and punish you, for example. And they will punish you hard, believe me. We have a specific cutoff for the credit score. For example, if credit score is below 450, we're already saying no, it's not worth to even get a risk. So we automatically reject the application. Yeah, and we check if a client has had already some bankruptcy before. It's already a flag. So guys, be responsible, because credit history always remembers this stuff, and in the future it can affect your future loan decisions, and it will, just also believe me. So be careful with your loans. Don't get into too much how do you tell it, into too much repay period or something like that. Basically pay your loans on time, pay your bills, and if you cannot, try to talk with banks about it so they don't put this data into the credit bureau, because it stays there and it will affect. How we validate the model. Okay, we have not so many time left. So basically, as I said, the Gini coefficient, discrimination power, measures the discrimination power, tells you how well you rank the risk. So between 40 and 70, the model, the decision model is a good model if it's between this range. KS statistics, it's max separation between good and bad distribution. Measures the biggest gap between goods and bads if we put like this on one line. PSI is so people over time changes. The customers, different customers can come, and it will affect, even though the model is the same, different type of customers can come, and you need to check it always. So it should be lower than 0.25. And there is some other tests which depends on already existing data, that basically you just get what you trained and you compare it with the reality and you see if there is a big difference. Yeah. Deployment in our company, we're using Fast API and the Docker. So it exists there. We just receive the request and we respond the request. That's it. Nothing very specific. The monitoring. It's not enough just to develop the scorecard, because scorecard over time will degrade. It's a fact. And you need to constantly monitoring, especially the score distribution and Gini drift monitoring. That will, it can be something like this. So over time, as I said, some people can come different, or just credit bureau data somehow change, product change, everything changes. So your scorecard should also track that. Sometimes you can do just a small ad hoc changes in this in the scorecard, but if the PSI, so the index of different people that comes to a business, change dramatically and it become more than 0.25, that means that scorecard need to be redeveloped. Yeah. Population shift becomes also due to the, again, government changes, new laws, the DTI stuff. You have a new advertisement for new products, for example, like to attract new people. These new people can be different type of in different economic situation. That's why you sometimes attract bad people, and it happens. Again, the key takeaways of this business: risk is a backbone of it. So risk makes you a profit or losses, and feature engineering basically is 80% of the work. You need to be very careful when you do it. Other the facts, Python just increases the speed of lending the loans, and just be modern, be fast, and that's how you adapt to the real world. Yeah, about the useful information, last thing. Highly suggest to read this machine learning last book. They have the in O'Reilly distribution there. So this machine learning for high risk applications. And yeah, that's it, guys. Thank you.